Evaluate the limit at x goes to 0 from the right-hand side of x raised to the x power. This is the indeterminate form of the form 0 raised to the 0 power. 0 raised to the 0 power is indeterminate. It is not 0 and it is not 1. It is to be determined. This is not a power and this is not an exponential. If we have a function of x in the base and a function of x in the power, that is, if we have the limit of the form x goes to a of f of x raised to another function in terms of x, g of x for instance, then we would need to rewrite it at the limit at x goes to a of e and then ln of f of x raised to g of x. Recall that e and ln canceled out. We do this because we want to bring down the g of x to the front of ln. We still have e, and in front of ln is now g of x. We rewrite ln of f of x. And in the exponent of e, this is now a product. And this product is of the form infinity times 0, most likely, so that we can use the L'Hopital rule. And so to find this limit, we write this at the limit at x goes to 0 from the right-hand side of e ln of x to the x. Yes, e and ln canceled out, but don't cancel it out. We just introduce it. We bring down the x, and then we write ln of x. The exponent is now a product, but to use the L'Hopital rule, we have to rewrite it as a ratio. Multiplying x is the same as divided by the reciprocal 1 over x. Recall that every time we have ln, to rewrite it as a ratio, we keep the expression with ln or the function with ln in the numerator. This is now a ratio. To use the L'Hopital rule, we still need to check the conditions of the L'Hopital rule. At x goes to 0 from the right-hand side, ln of x goes to negative infinity, and at x goes to 0 from the right-hand side, 1 over x goes to positive infinity. The expression in the exponent is the limit of the form infinity over infinity. We ignore the plus or minus. We now rewrite this limit. Exponential functions are continuous so that we can move the limit inside of e, and then the limit at x goes to 0 from the right-hand side of ln of x over 1 over x. We will keep rewriting e, and then take the limit of the power. The limit of the power is of the form infinity over infinity, so that we can use the L'Hopital rule by taking the derivative of the numerator and the denominator separately. In the numerator, the derivative of ln of x is 1 over x. In the denominator, the derivative of 1 over x is negative 1 over x squared. This is e, the limit at x goes to 0 from the right-hand side, and we rewrite it. 1 over x divided by negative 1 over x squared is the same as multiplying negative x squared over 1. This is e, the limit as x goes to 0 from the right-hand side. Negative x squared over x is negative x. And at x goes to 0 from the right-hand side, negative x goes to 0, so we end up with e to the negative 0, or simply e to the 0. But e to the 0 is 1. This limit at x goes to 0 from the right-hand side of x to the x is 1.